Hey, this is OXTF, and today we're looking at another Hack the Boo challenge. This is a forensics challenge, and it's called Poof. And I really like this challenge because it's a kind of a mini investigation all in one. We're going to have a series of questions to answer in order to get our flag. Let's go ahead and take a look at the files we get with this download. It comes with this forensic poof.zip, which I've already unzipped. I don't know what this .boo file is. We can look at that and say, to see what it is, but it just says data. We can do xxd on that same file. Maybe put that into head to take a look. Still just looks like kind of random data. We got a memory dump, and that's a Linux memory dump, so that's good. We can probably some memory analysis here. We have a packet capture that is a packet capture, cool. And then we also have this Ubuntu profile zip. We can take a look inside that. Ubuntu like that, and it's got a volatility tools Linux module dwarf. It's got a boot system nmap. Generic. Basically, these are the files that I need to allow volatility to do memory analysis. And these files help it say, if I can tell it, this is I want to use this profile, this Ubuntu 4.15 profile, and then it'll know exactly like where things in memory should be, things like that, so it can actually perform memory analysis. So we'll get into that in a minute. We also have a Docker instance that we spun up, and so we can connect to that. See, I need to replace the semicolon with a space here. And this is where we get the story for the challenge. So they're developing a new game for Halloween. He's the leader. He wants cutting edge stuff. He found a private Discord server. And one member suggested he tried this new Python library that provides enhanced game capabilities, right? So quite simply, he tried it, and now everything he has is encrypted. So clearly it was kind of a malicious thing. Now he has a memory capture and network traffic of the incident, and can we help him recover it? And so we have this first question, what is the malicious URL that the ransomware was downloaded from? Before I get into that, I'm going to go ahead and just take a second and talk about what tools we're going to use for this challenge. So we're going to definitely use Wireshark. That's our pcap analysis tool. And we're going to use a tool called volatility. And volatility is a great memory analysis tool. Unfortunately, it's written in Python 2, and I try really hard at this point not to use tools in Python 2. But the Volatility 3 framework exists. It's completely different than the part 1 that's written in Python 2. And things like this profile is made for Volatility 2, so I'm going to have to use Volatility tool too. There is a really nice post here. I think it's on Sean the Geek, I believe is what it's called. Let's see if I can find it. Volatility installing volatility 2 on Debian. So if you're working on a machine that doesn't already have volatility on it, these instructions are really nice for getting it installed. It'll set it up. I don't know if your computer is like mine, but I use Python as Python 3, and so Python 2 is for Python 2. And this will get it set up for you just exactly how you want it, and it won't stomp over and take over and make defaults or anything like that. So I'd recommend this article for getting it installed. The other thing that's worth thinking about here is, let's see, if I want to use this, if I do, once you follow those instructions, you can just do vol.py and it will run. And if I run this, let's see, with the --info flag, actually, in fact, I'm going to run it into less, so I get the top here. It shows you the profiles available, and it looks like I already have this profile on my system. Let's see. That is because if we look in local lib Python 2 site packages volatility plugins overlays Linux, and you'll see right here is that file I've dropped right here. If that file is not there, then that profile won't show up, and then I can't use that profile in volatility. So I want to copy that file into this directory, and it's going to be local to wherever you installed. If you follow the instructions I just showed, you'll be in this directory here. Might be somewhere else if you do something else. With all of that, let's go to the first challenge. What is the malicious URL the ransomware was downloaded from? And so we'll do Wireshark on, I already forgot what it was called. Nope, not Candy Dungeon. Poof capture. There we go. And we'll open this up. I've done a couple videos showing Wireshark analysis so far for this CTF. Just like those, I'm always going to start with the conversation statistics. And this one's really simple. We've got one set of IPv4 addresses talking to each other, exchanging 6,000 packets. It's a single TCP stream. So no noise to filter through here, just one TCP stream to look at. With that, we'll go ahead and do follow TCP stream. And it's a single GET request to the host here is files.pypy.install-install.com. Now that's not the standard Python package index host, so that's suspicious. That's, again, we got malware from it, so it makes sense. This is kind of a malicious thing. But we've got the answer to our first question here. It looks like he's downloading a package, pygaming dev 1337 tar.gz. So we can come over here, go back to this. Let's see. They want the format with the HTTP, paste that in, and we need to get the full path. So grab this tar.gz, paste that, and we got the first problem correct. So what is the name of the malicious process? There's two ways to go about this, and I'll show both actually. The first way, the way I originally tried to solve this, is actually we can come up here to File, Export Objects, HTTP, and so it's going to show us all the HTTP objects in this pcap, and there's only one. And here it is. We can save that, and we'll just save it to a file here, and we can close this, minimize this. And so here we are. We've got that file. I'm going to make a directory called malware just to put it in. Move pygaming to malware, cd malware, and we'll go ahead and tar extract the file pygaming there. And it gives us a directory. We'll go into it, and there's a single file in there called configure. If we run file on it, it is a elf executable. So that is the binary that got downloaded and run. It seems very likely that that's the process that would have started. So we can take a guess right now that the answer to this question is configure. We don't totally know that, so we did get it right. Good for us. If we open up a new window here, this is where we can start to do volatility. And so we can do our vol.py, and let's see. So we got to give this. If we look at, we got to give it a image to use. So this is, we're going to use our mem.dump, and then we got to give it a plugin to run. So we'll run like we could run like the Linux psaux is a good plugin to give it, and that'll give us the, oops, okay, psaux will give us all the commands and the command lines run. Now I ran this and it gave me an error, and it said this command does not support the profile Windows XP SP286. So the default profile for volatility is this Windows XP. I don't want Windows XP, so it's looking through this memory thinking it's Windows XP, right? But it's not, it's Ubuntu, so we have to fix that. So we have to come here and say, yeah, let's go dash profile equals, and then I better get it, let's see, vol.py info grep Ubuntu. Let's grab the profile name, hopefully. There it is. We'll grab this, paste that there, and now we'll try it. And it's going to start printing the PID. And so here we have the different, it's the process list. If I ran a psaux on my own system, this is the kind of stuff I would get. So I kind of can skip through all these kernel threads. When they're in brackets like that, it's a kernel thread. So nothing too interesting here. All kind of looks like default stuff. But I get down to the bottom here. I've got this Python 3 stuff running here. I've got SSHD. These are all still root stuff. And then here now I've got processes running as the user, because you see the ID 1000. It looks like there's SSHD as developer, there's bash, and then there's configure. So here I can see the process name also is configure. Another neat plugin we can run is bash to show us the bash history for any users in this memory dump. And this is, we can see even more definitively. So they run an ls history. Let's see, they're powering off. Okay, so now they're going into their Python game directory. Here is where they get the malicious package. They extract it. They go into the directory and they run configure. So he has now run the malware. We can now feel pretty confident configure is the answer. So all of that, let's go back to this. What is the MD5 of the ransomware file? So we already pulled it out, right? So we can do MD5 sum of configure and get an answer right here. And we paste that in here and we're looking good. All right, so what language is used to develop this ransomware? So we got the file. Just like I believe I've already posted my first reversing video from the CTF, and I went into good detail about strings there. We're going to want to use the strings here as well. Always start with strings, and we'll start with like n10, and we'll pipe that into less so we can take a look, and we can start scrolling through here and seeing what we get. Some stuff, nothing jumping out at me quite yet. Now I'm starting to see stuff. So py don't write. Py sounds very Python. Cannot open PyInstaller archive. PyInstaller is a big keyword here. We're going to want to note that. If we keep going down, we still have PyAir, PyList. You know, all of this just sounds like Python to me. Anything else interesting jump out? We have enough. I think we have our answer. Basically, it's Python. PyBootloader. So let's go ahead. We'll go ahead and see if we can answer that from here. We'll say Python. Sounds right. After decompiling the ransomware, what is the function? What is the name of the function used for the encryption? So this is where it's starting to get pretty challenging, right? So we have we noticed that PyInstaller string. PyInstaller is definitely a great hint here. So we're gonna want to run. There's a couple tools we're gonna want to run here. The first is called. Let's see if I can actually remember how to type this out. PyInstaller, like that. And what this is going to do is it is a Python script that will pull Python bytecode out of a PyInstaller exe. So PyInstaller is a tool that will take your Python script and package everything it needs, all the libraries, the Python binary itself, into a single executable, either Windows or Linux. You tell it, and then that makes it runnable. So what this is going to do is it's going to pull out the bytecode. So if we do, I believe I have, let's see, Python 3 opt pyinstxtractor. Yep, I have it on here. So I can pyinstxtractor.py, and I will give it this configure binary, and it's going to run. And so let's see, it's running, it's processing, blah, blah, blah. Now, you want to pay attention to these warnings. These are important. The script is running in a different version of Python than the one used to build the executable. Please run in Python 3.06 to prevent these errors during unmarshalling. So basically what this is saying is I need Python 3.6 to get this right. And if I try to keep going now, it's going to be all screwed up and I'm going to have to, it's not going to work. So that's annoying. It did create this configure extracted directory, but we're going to go ahead and remove -rf configure extracted. And we need to get Python 3.6. Python 3.6 is pretty old. It's kind of hard to get a handle of. And I think the easiest way to go ahead and do this actually is to do it with Docker. So I'm going to do sudo docker run -it Python 3.6 -alpine. And what this is going to, and I'm going to do sh. And what this is going to do is it's going to go out there and pull, since I've done this before, you didn't see it, but it went out and pulled the latest Python 3.6 Alpine image, and it's dropped me to a shell in it. So I now have a shell in this image. And so I can do, let's see, I can do Python 3 -m pip install. The other tool I'm going to need, which we didn't talk about yet, but we're going to have to uncompile 6. And it will install into this image that I'm running. And I can do wget, let's grab this right here, because we're going to want this copy of this script right here. And when this script is just kind of a standalone script, so we can just get the whole thing here. So we can grab the URL of the raw script, and we can paste that there and wget it. And now we have the pyinstxtractor thing saved there. The other thing we need is we need to get our image in there. So let's go into malware here, and we can go into pygaming, and we can do docker copy configure. Oh, before we do that, I guess we need to do docker ps. I'm probably have to run that with a sudo. And so we can see the name of my container right now is Hopeful Babbage. Okay, so we'll do sudo docker copy configure into Hopeful Babbage. No tab complete on that. And we'll just put that at the root configure. So now, if we come here, we have our configure file. Sweet. So now we can run, if we run python-v, we'll see we're running Python 3.6, so we got the exact version we want. So we can do Python pyinstxtractor configure. And now you'll see we get this running with Python version 3.6 and no complaints. So we're happy here. So we can go into configure extracted, and these are all the different libraries and different pieces of the binary that we need. So we have this configure.pyc file. That's going to be the That's going to be what we'll want. A PYC file is Python compiled bytecode. So if we were to like cat this, it's just going to look like junk. So this is where we use uncompile 6 on configure.pyc. And this is going to print out. It takes the PYC code and puts it back to Python. So let's go ahead and we will save this to a file in the configure.py. And then we can come in down here. We can do sudo docker copy hopeful babbage / configure.py to here. And now we have configure.py right here. And we can actually use we'll use VSCode to open this up and take a look. Here's our configure.py. And we can take a look. So they got a bunch of functions here. Let's scroll down to the bottom, see if we can find, yeah, here's so it runs main, and then in main, it's going to get the username. It's only going to do encrypting if the username is developer lead. That's not realistic for malware, but I think that's because HackTheBoo doesn't want to send out a binary that if you accidentally run it, starts encrypting your stuff. Then it's going to get the directories, that downloads the documents in the desktop. It's going to loop over them. Files is equal to this function on directory. And then for each file and file, it's going to call this function here. So that looks like it. MV18. Let's go up and check that out. What are we looking for exactly again? What is the name of the function used for encryption? So it looks to me like this MV18 function right here is, it's opening and reading a file. It's got some encryption. It's encrypting, and then it's calling this function, which I'm guessing is writing it back, maybe encrypting it. So let's go ahead and try to submit this. And we're correct. So decrypt the file, the given file, and provide its MD5 sum. Cool. So now we have to decrypt. We've got this function. Let's go ahead and grab this data or this stuff right here. And we will, new file, decrypt.py. I always like to have my shebang. MD, Python 3, import sys. We're going to use sys. We'll talk about that in a minute. We don't need that. We will unindent that. So we're going to open up a file name. We'll get sys.argv1. So that way, whatever our first argument on the command line is, we'll read it as binary. We get our key. We get our IV. We'll create an AES object. We're going to need to import that. So we'll import, let's see. We'll grab it from here, however they did it. From crypto.cipher import AES, copy that over here to decrypt, save that, and now we're not seeing errors here. And so the last thing we're going to do is we're going to take our cipher, and we're not going to encrypt. We're going to decrypt data, and we'll call this plain text. Oops. Plain text, and then we can do with open this.argv2. So the second argument we passed in for write binary. As f, and we'll do f.write plain text. And that is a, let's see, don't show that. Okay, and that looks like a decent working thing. So we can go to we can even do it in here. We can do a terminal. Let's go up. Forensic poof. So now if we do Python, oh, where's my decrypt function? It's way down there, huh? Let's see, malware, pygame, decrypt, and we're going to take in candydungeon.boo. We're going to want to put out candydungeon.pdf. And if that worked, let's see, we can come in here and we can do xdg open candy candydungeon.pdf. And look at that, we got a PDF file out of here. I don't think there's anything particularly interesting in this PDF file, but we got a PDF file. So what we really want is the MD5 sum of that same PDF file. Grab that, paste it in, and we got the flag. So this was a really neat challenge because we got to start, with just the pcap and the memory analysis. We pulled the malware out of there. We did some malware analysis, a little bit of, it's almost a reverse engineering challenge by the end. But now at the end here, we get our flag. So going to call this one here. Thanks for sticking around till the end, and I'll talk to you next time. Bye.